Basically, my talk was born from the frustrations with Json. Yeah, okay. First of all, I'm a Python JavaScript programmer at Mirantis. We build OpenStack clouds. Our flagship product is Fuel. It's the best OpenStack installer on the market. It's open sourced. I'm also a hobbyist Hascaller, and in November I'll be a father, so it's like a second full-time job. Yeah, so thanks. My presentation is unfortunately research-based and not experience-based. So, yeah, but talking with you guys, it's nice to hear that not many people know what's going on here. So, you know, this somehow proves that such research is required. There's some code on GitHub in my repository, so you can check it out, and there's more information there and some random remarks. I tried to use as many languages as possible, I think 6 already, so you can check out stuff if you want to start out with one of these formats. So basically, let's say we have this setting that we're building a chat room server, so there are users who chat in some rooms, which are either private or public, and they send messages between each other. And so we have some schema to send the data between clients and servers, something like that. And we also want to be able to version this schema so that if we need to upgrade the code with some new data, then this schema will be easily versioned. So let's say that in version 2, the user has some additional fields like first name, last name, age, and just for fun, list of strings. Yeah, so say this is our user, and he wants to speak with his pretty wife. So basically, the data associated with this user is something like this. And then you combine it with a schema and serialize it to get a JSON, right? Well, we have 3 variables in this system. The data that changes, because you can have different users, which is quite obvious. But the schema can change. As you saw in the previous slides, you can have different versions over time, and you want to be able to serialize it. The best way would be to keep backwards compatibility, right? And then the serialization format can change. So with JSON, you produce a string that looks like this, but maybe you want to create some binary format because it might be better, and in fact, it is usually. So basically, if you throw out the data out of these variables, you leave out schema and serialization. This is a data exchange format, right? So let's talk about JSON. First of all, what is bad about JSON? Because the good part is its flexibility. You can serialize at any time, anything, and you just are all done. The bad part is, first of all, it can be serialized in only one way. So basically, well, up to white space, right? So you can insert new lines in some places and get pretty printed text, but otherwise, there's only one method to serialize it. Another bad thing is that with every message, you send the schema over and over again. So suppose you have a client in some version and a server in the same version, and they talk to each other, and you constantly send the schema, wasting bandwidth and resources and stuff like that. You could just put the schema on the client and on the server and just exchange pure data without constantly shuffling the schema. Another bad thing is that you have no control what changes over time. If server starts to send first name, a camel case or snake case, the client has no quick way of quick way is throw error, right? And another thing, there's no built-in validation. Basically, if JSON string is a correct JSON string, the content of it is not important to JSON, right? Whether age in this example is an int or a string, it's not JSON's concern that it is valid contextually, right? You can use JSON schema, but that's like plugin to JSON, right? So you have to like do additional step. And well, it's not readable because this is a sample from the Twitter docs. There are only 2 tweets here. And well, they fit on a page. And basically, you still need some tooling to get out the data you want. I dare you to find the text of the tweets right now. So, yeah. XML. Well, XML is even worse because you duplicate the schema with ending tags. So you have twice as much schema data than in JSON. And in fact, Wikipedia says XML is not human readable. So, yeah. Eric Nagam, former Emacs developer, wrote, "Those who think it is rational to require parsing of character data at each and every application interface are literally retarded and willfully blind. But alas, people prefer buggy text formats that they can approximate rather than precise binary formats that follow general rules that make them as easy to use as text formats." Well, you can say, I use binary, I use message pack. Well, true, it's partially binary, but the problems are the same. You do not have validation. You have only one serialization method. And you still send the schema all the time. So you just basically change the serialization method in JSON. So message pack is not the solution. So let's explore the topic. What are the other options? The first one is abstract syntax notation 1, which is a very old format. Was created in 1984 by the International Telecommunication Union. The spec was revised many times. There is no ASN.2. When they created, they thought there would be possibly some other formats, but for 30 years, nothing else happened from that committee, so there's only ASN1. And basically, it's used even if you don't know about this, because if you have a cell phone, you're using ASN1 right now. So it's heavily used by telecommunications industry. It's present in cryptography, in certificates. It's used in RFID, LDAP, and stuff like that. So it's very, in mission-critical applications, it is often used. To show you what an ASN1 file looks like, sorry, I have to sit. Okay. So this is an ASN file. Okay. What you can see is that you define a module. You name it chatroom protocol. You surround it with begin and end tags. And inside you insert types. So for example, user. User is an object, which in ASN is called sequence because the fields are ordered. And he has an email of type string. Size is 1 and 40, between 1 and 40. Username. Then you have room type, which is like enum type. It's a choice between private and public. You can, of course, use the types that you defined before. So the message can use the user you defined before. And this ellipsis sign means that in the future versions of this message, user can have additional fields. So basically, you're explicitly saying that this model can change in the future. Usually, you want to have everything to be able to change. So you would have to put ellipses everywhere. But they added this extensibility implied. So basically, you add extensibly implied right at the module definition, and then you don't have to add this ellipsis sign everywhere. So this is what an ASN file looks like. It's just a specification for the schema. In second version, we extended the user, so we add first, last name, age, and sequence of strings. So sequence of strings is just sequence of UTF-8 string. And we assume they're all optional, right? Those fields before were required. What are these things inside, what are those numbers inside square brackets? Where these are called tags. Tags in ASN1 are optional, but are strongly recommended to use. Basically, if you have two optional strings next to each other, most of the binary encoders won't know which one you sent if you send only one of these. So tags are there to guide the encoders to tell them which field is this. In other formats that I will show you, these tags are required everywhere. In ASN1, they're optional because it has so many different encoders that some of them don't need this information. But usually it's suggested. So the advantages of ASN are that you can add very complex validation. For example, you can have integer ranges. You can have string ranges. So it automatically validates your data as it encodes and decodes it. It can even parse regular expressions according to the spec. So you can have email and already check that it's a valid email, right? Many encodings are supported, including XML one, so you can be happy, or Json, right? So, but the most interesting ones are binary, because in binary encodings, you do not send the schema all over again. The PR encoding is quite interesting because it's very dense encoding. If you have an integer range like the one on the first line, there are only two possible integers, and PR is smart enough to deduce that these integers require only one bit of information. So it won't send like the whole long integer, it will only send one bit there, depending if it's the lower or the upper one. Yeah. Yes, exactly. So, okay, I didn't say it, but when you have this ASN file, you basically then get some library for Python or C or Java. You compile the ASN file, and then you generate Python, Java, or C modules. And then you use the models in there. Yeah, you add. Yeah. No, it's not. No. The protocols and the encodings are designed so that it is extensible in the future. So yeah, so basically the client and the two ends have to know about the format, and then they can exchange information. So it has another cool stuff, which is parameterized types. Basically, you can create a type function that takes two arguments in this case, and returns a sequence, and then you can instantiate that type. So that's quite cool, and not present in other formats I'll show you. Bad things is that it's 30 years old, so there are a lot of legacy stuff that wasn't removed. There are so many string types. One of them is video text string, which is supposed to support Minitel, which is French pre-internet internet. So that's quite cool. The ones that you should use is UTF-8 string and IA5 string. That's the two that are interesting. The bad part also is that there aren't many good open source libraries for this, because the language is very complex. It has very cool features, but well, there's not a big open source ecosystem around it. There's proprietary library from OSS Noclava, but it's proprietary, not free. So that's the bad side. And if you look up on the internet about ASN1, there are so various opinions about it. Many people hate it, many people like it. In my opinion, there hasn't been this critical mass that would create great tooling there, and to support these advanced language features that are there. So it hasn't reached this bandwagon effect. But you have ASN1 parser probably on your computer, because since it's used in certificates, if you have this OpenSSL command, it has asn1 parse subcommand, and I suggest you either check out my code and encode some stuff with this and decode it with asn1 parser, or you can just take a private key and you can decode it because it's just dr encoded with the asn1, and just you can look at the primary numbers that are inside. There's also a JavaScript browser for this. It looks like this. So you basically insert base 64 encoded string there, and you can just see what fields are inside. So that's one tool. Second format is protocol buffers made by Google. Current version is version 2. Version 1 was never released publicly, and version 3 is about to finish, about to come out. There's only one serialization protocol. With ASN1, you had many different choices. Here you have only one binary format. But there's a third-party JSON encoder if you like JSON. ASN1 with PR encoding can be more compact if you need this, although proto-buffers are, in some benchmarks, are the fastest. And tags are required contrary to ASN1. That's what I said before. Well, this is used by Google, obviously. Hadoop, OpenStreetMap uses it to save data. Ubuntu One also used it before it was closed. There's 5 officially supported languages. Unofficial list is longer. There is no built-in RPC because sometimes you might need it, and the next protocols I'll show you there is a built-in RPC, but Google recently released gRPC, which is RPC framework built on top of proto-buffers. So it's worth taking a look there. To show you what they look like. This is a proto file. It has to start with package, whatever the name of this package is. Then you create objects. So it proto-buffers, it's called message. There's this required keyword, and the tags are after equal sign, consecutive numbers. And these are required. So in version 2, we added some optional strings, and then array is written in quite strange format. It's called repeated string in proto-buffers. But other than that, you again compile it into your language and just instantiate the models. It's all the code is on this repository. So if you want to take a closer look, you can see it. I stumbled upon a question: why didn't Google use just ASN1 and invented its own format? And it turns out they never heard of it before. And the comment is quite nice. Those lucky bastards. Thrift, that's another one. It was created by Facebook, but then now it's part of the Apache Software Foundation. It's open sourced. RPC here is built in, so if you need this, you have it out of the box. And it has a nice pluggable architecture, so you have many serialization formats, binary, compact, JSON, and stuff like that. But you also have pluggable transports. So the empty transport saves stuff to memory. The HTTP client transfers over HTTP. So it's all connected with this RPC. Tags are required, and if you need a good introduction, there's this Thrift missing guide, which is quite okay if you want to look in detail. The list of officially supported languages is quite long, but you have to take into consideration that not all protocols are supported for all languages. So you have to look carefully if you talk between different languages that they both support the same protocol and the same transport. Facebook obviously uses it. Hadoop, Cassandra did use it, but switched to CQL. Evernote uses it, and Last.fm also uses it. I created a simple server in Haskell for Thrift, and I stumbled upon a bug that the Cabal package, the package for Thrift didn't have a license file, so Cabal failed to compile it. And it would be okay. I mean, it's a simple bug. You just add the license file, and that's all. Well, this bug is still valid since February. And the reason for not closing it is that they voted the version 0.092, and they will release a fix in 0.93 sometime in the future. So if this is the state of whole Thrift, it doesn't say good about this, but well, I hope it's not that way. I'm not speaking from experience, so I don't know if it's true like for all code base of Thrift, or is it just one single issue. Well, Thrift is quite similar. It has a more C-like syntax. So you can create your type definitions, like integer 64 is timestamp, and you have structures, and tags are like prefixed. Your fields are prefixed with tag numbers. Arrays look quite funny because it's like C++, yeah, list of strings. So whatever you prefer. And then again, you compile this file into your language, and then you can use the modules. Captain Proto. It's very similar to the previous ones, but it has two funny things. One is that there's no encoding steps. In all the previous protocols, you have to create your object, and then you serialize it into some format. Well, in Captain Proto, when you add data to the object, it's serialized like on the fly in memory. So serialization is just dumping memory to your network socket stream or something like that. So they say they are infinitely faster than protobuffers because protobuffers takes some milliseconds to serialize, and they have 0 seconds to serialize, so they're like infinitely faster. Supported languages, there are 5 of them officially, including RPC, because they have also RPC framework. If you throw out RPC, there's more languages. So depending on what you need. And another second thing is that the RPC is actually quite interesting because it's promise-based. So everything you do in the RPC, you immediately get a promise, and then you can like virtually take the data from that promise and make another request to the server. So you can like chain request immediately to the server, and then just wait for it to finish processing. So it's quite nice. And if you look at the RPC documentation, at the bottom, they refer to the language called E, which is quite interesting, especially in this conference. It's a language with promises built in. So you can either synchronously instantiate objects and operate on them. That's like the first example. And the second example, you can do everything asynchronously. So, but if you have like a promise for an object, you cannot go synchronous with it anymore. Yeah, so this is quite an interesting fact. Major implementations of E are E on Java and E on Common Lisp. So with Java, you get like big ecosystem. And the last protocol I want to talk about is called Avro. Avro is completely different from the previous protocols in that it is not compiled anymore. You just import the library, and you create the schema in your program. And basically, there is no compilation step for the modules. It just takes the schema and the data and serializes it immediately. It is developed by Apache Software Foundation. It is used in Hadoop primarily. And it has dynamic schema, like it can change with your program. Can be specified in JSON or in custom language that Avro created. And serialization goes into binary or into JSON. And there are no tags because fields are optional. And actually, yeah, supported languages are quite also big list, officially at least. And so, since the schema is dynamic here, you have to send the schema along with the message always. So it's like you have JSON schema and pack it together with JSON, serialize those together and send it over wire. And to decode the message, you need the schema it was encoded with. And for versioning, Avro has a very smart, well, not very, but has a smart algorithm that you can, for schema resolution. So basically, it looks like this. You have an encoder, you put schema version 2 and data version 2, encode it into binary, and then the reader decodes it back again into schema and data. But the reader says, okay, but I operate only on version 1. So he feeds this schema resolution mechanism with version 1 schema, and the schema resolution mechanism produces data in version 1. Well, it's not always possible, but in Avro, the tags that were in previous protocols, those numbers, in Avro, those tags are names of the field. So basically, it looks like this. So here's schema version 1. You have type record, name is user, and the fields are email and username. Those are both strings. And in second version, we have additional fields, first and last name, and you provide the defaults for them, like empty strings. And then the magic is this. You have a writer in schema version 1, and you write data in version 1. And then you can read it with both versions. So the reader reads version 1 and converts it to version 1, so just reading version 1 data. Or the reader can read in version 1 and convert into version 2, like embed the missing fields into version 2. And the same for version 2. The writer can write in version 2, and the reader can deserialize it in either into version 2 or version 1. It looks like, okay. Basically, when you run this program, it looks like this, that version 1 to version 1 gives like version 1 data. Version 2 to version 2 gives version 2 data, obviously. But version 1 to version 2 embeds the defaults in the version 2, while version 2 to version 1 removes those fields that were there. This is how it acts for records. So it's a simple example, but it works recursively. So if you have fields that depend on, if you have types that depend on other types, it can like recursively do the job for you of translating between two different versions. So this is quite cool. And it actually seems a good way if you want to start out migrating from JSON into some other format because of its dynamicity. So this is what is nice about Avro. And in fact, the serialization is quite fast there. So some final random remarks. If you add a required field sometime, then it is required forever in all future versions of the schema, which is quite obvious, except for Avro, where you can just leave out some fields, but then you have to provide the defaults if you want to be compatible in both ways. Notice that this serialization can be used not only for sending data over wire, but you can also save this to database, which is quite obvious, but you have to somehow realize it. So it's like, transporting the data into the future, right? So you just have the transport is the database and just save it, right? The serialized. And in fact, it is done like protobufers in ActiveMQ. ActiveMQ uses protobufers to save the data, right? Migration, if you have an API, then migration is quite easy because you just use content type headers and content encoding. So for example, for this ASN one, you could add content type header like ASN1, something like that. And encoding would be like one of the choices for the encoding plugins. So you can like migrate seamlessly with your API or whatever. There are performance and size comparisons. I didn't have them here on the slides, but they are available for C# and Java. But well, for Python dynamic languages, you need like something like C bindings for it to be fast. And big companies create their own serialization formats. One worth mentioning that wasn't here is Bond from Microsoft, which has a nice pluggable architecture, and the core of it is written in Haskell. So yeah, good job, Microsoft. So that's it. Thank you.
This is just a comment, but you had on your slide, you were wondering more companies using protocol buffers at OpenWhisper systems for Signal, TextSecure, and Redphone, the encrypted communications apps. We use protocol buffers, so there's open source code for that online in Java, Objective-C, and JavaScript if people are interested.
Okay. Flat buffers? No, haven't heard. Yeah, okay, no. I didn't like analyze them all.
Anybody else? Okay.
Thank you.